Hello, my name is Charles Taylor. I'm a member of staff at the University of Leeds in the School of Mathematics, and today I'm going to talk a little bit about expectations of random variables. This will include a number of different issues. So first of all, we're going to define what a random variable is and go through concepts of a sample space and probabilities. Then we'll talk about expectations. And then finally, which is perhaps the most interesting part of the lecture or the podcast, is to talk about why in the sample variance do we divide by n minus 1 rather than by n. And that hopefully will be clear after introducing all these concepts. So first of all, what is a random variable? Well, it's pretty much what it says on the tin. So it's something that's random, something that varies. It's not deterministic. It doesn't always come with the same value. It doesn't vary in a way that we can predict it. So it's unpredictable, and it has a number of different features. So usually we'll denote a random variable by a capital letter, and I'm going to use the letter X. It could be another capital letter, but usually fairly consistently is a capital. So in order to describe a random variable, we need two different components. The first is the concept of a sample space. And I'm going to use, for a sample space, a Greek letter omega and a capital Greek omega, which is the sample space of our random variable. Okay, so a sample space is really a list or a description of possible values that the random variable can take. And this could be a very short list. So one example might be that omega is simply the values 0 and 1. So that will be our first example of a sample space. So this means the random variable could take a value 0 with some probability, or the value 1 with some probability. And this is an example where we have a finite list of possible values. It could be a slightly longer list. In fact, it could be an infinite list of values. So we could just put some dots here just to denote that the sample space omega actually has an infinite number of values, in this case any integer, and that would also be a possible sample space for random variable x. So it just says x can take any value, theoretically, of the positive integers.